So this is a set of slides that we put together for VMware Barcelona as well as Las Vegas. It's actually a subset of those slides because we only have 40 minutes here. So the idea is to go through the very first 20, 25 minutes to give you sort of an overview of what's going on in terms of cloud-native applications, DevOps, and trying to demystify those buzzwords that you keep hearing. And then in the last 10, 15 minutes, we're going to talk more in details, well, as much as we can do in 15 minutes, about what VMware is doing in this space. So by show of hands, how many of you have actually been playing with Docker and containers? You don't count? Okay, very few. So that's good, because the idea here is to sort of level set an audience that comes from different background, right? So from a traditional VMware, vSphere kind of background, and sort of bring you to a more, into a level that allows you to at least understand those keywords that we keep hearing about. We're going to start at the very high level with some thoughts, and then we are going to go a little bit deeper into how these technologies are helping with what we're showing here. So what I usually show in this slide, and what I usually start with, is the difference between how we buy things and what we buy. So I'm going to go through this very quickly, but the idea is that we used to buy like this, right? Going to the shopping malls and doing all this crazy stuff. But nowadays we are doing more like this. Certainly my wife is doing more like this on Amazon Prime. But this is not the real thing. The real thing is what we buy today, right? So, and this has ramification both from a business perspective as well as from a user perspective. So there is this story of, I think this is John Deere, that built these tractors. And the John Deere's customers are not buying these tractors for the mechanic of the tractor itself, but they buy this tractor for the application that comes with them, right? So they can do better their job in the field by using these applications that comes with those tractors. And this has also ramifications into our own life, because a few months ago, I bought this scale, right, at a shopping mall, not on Amazon Prime, because I bought this, not my wife. But I bought these because of this application that comes with it. So I didn't really care about this application, this mechanic of the scale here, because what I wanted was an application that could monitor my weight. And you can make joke, Duncan, now, about my weight and my breakfast. Yeah. So to me, I mean, when you keep hearing about Airbnb not owning hotels and Uber not owning cars, and I don't think that that's the point. I think that the point here is the user experience of you standing in the middle of the road at midnight and finding it more convenient to book a Uber rather than trying to call a taxi with the traditional method. So the application is actually changing our life, both from a user perspective as well as from a business perspective, right? So that's a very key point. So software is actually giving the organizations an edge, right? And most of the things that we're discussing here may not have a direct impact on your organization, because maybe your organization are using technologies in a different way. But the reason for which we keep talking about cloud-native application, DevOps, and all these sort of things is because this application gives those organizations an edge, right? And if you think about how it works, usually in like 99.9% of the organization, it works like this, right? So there is IT that is helping developers developing application and putting them in production. So if you look at the speed of these, it's pretty much like this. It is moving, but it's not very fast, right? So the idea here is that an organization that has a traditional way of doing things is not giving a great experience to the end user. And the idea is that from the time someone has an idea that can change the life of the user to the moment that the user actually gets that experience, it could be months or years, right? So think about putting in production a new version of the application. That's how usually is for most of the organization. The new organization, those that are using these buzzwords of cloud native application, DevOps, and these sort of things, they have a very different model, right? We're going to explore these in the next few slides, but we're not going to go very deep. But there is this idea of DevOps where developers are working together with people that understand IT. And then there is this notion of microservices. So instead of having that monolith that we have seen in the previous slide, where everyone have to contribute to, there is this notion of having many more little pieces that your application is comprised of, so that those pieces can be independent from each other. So there is a contract between these different teams that they need to build a service that exposes APIs that someone else can consume, right? And this has obviously great ramification into the benefits that this will give to the user using these small components independent with different release cycles, because then you can go actually at a much faster speed. And not all of them needs to go to a much faster speed, right? Because there are some of these pieces like this one that is moving slowly because it doesn't need to move fast. But there is these other pieces that needs to move faster because that is where the value in the end user experience is, right? So the idea here is that by implementing these different ways of doing things, you can get an experience to the user that is in the hours or days, right? So you may hear people saying that Amazon or all of these kind of leading edge organization deploy in production like, 10 times a day or even 100 times of days. That's how they do this, right? So that's kind of the very basic idea. So in order to be able to do this, there are two buzzwords that it is worth exploring here, which is DevOps and cloud native applications. So the first one talks more to the operational aspect of how you do things. The second one, cloud native application, is more associated to the architecture of the application. So if you think about a traditional model of how things work, there is IT, right? Inside the organization, there is an IT organization that is pretty much responsible for everything, right? So from templates, blueprints, and everything. And this organization usually supports the developer. Typically, and the most advanced organization has this idea of an enterprise cloud where the developer can go and self-service provision typically virtual machines, right? So that they can start developing the application and doing the stuff that they need to do, right? But then what happens in the end is that this guy that is developing this application code needs to go back to IT with the jar file or whatever the outcome of their work is and put into production, put that code into production, right? And that is usually what we say, this is where the shit hits the fan, right? Because that's the complex thing, right? Once you have this jar file, your application, how do you go from having that jar file on your laptop, which is where you have developed that application, onto hitting the end user, right? So that's where usually the shit hits the fan. The other thing to notice on this slide is that pretty much everything, if you think about DR, HA, scheduling, backup, resiliency, everything is managed at the infrastructure level, right? So this guy is typically only charged with, you need to develop these features, and then once you have those features done, you have to give this jar file to someone to operationalize it, which is where the shit hits the fan, right? So the DevOps model, so I want to say upfront that if you ask 100 people what DevOps is, I mean, they will give you like 100 different answers. But one of the aspects of DevOps is that this is changing dramatically, right? So this landscape is changing dramatically. So in the new DevOps model, basically what you have is the implementation of that saying that was coined by, I think, the Amazon CTO a while back, that you own what you build, right? So once you build something, you actually own it, right? So it's not like you're taking what you have done and you give it to someone else. You actually own it all the way into production, right? So the idea and the posture that is being created in this leading edge organization looks something more like this, right? So there is capacity on the bottom part of it, and this capacity is usually both private cloud or public cloud. So they have this idea of being able to deploy both on-prem or off-prem. There is IT obviously taking care of the plumbing at the very low level of the private cloud side of things. But IT is also taking a different lead in this picture, where basically they're going to have DevOps into productionalize these applications, so to speak, right? So there is this idea that those teams that we have seen in the previous slides, where there are multiple teams working on a subset of the big picture of those microservices, there is a component, there is a development component, and there is an infrastructure-aware component inside those teams. So they're able to do things like operationalize that application code that the development team has built, right? So this is kind of a way to look at these DevOps things. And as I said, there will be people saying, well, that's not actually what DevOps is, but this is just to give you a very high-level idea of what this is. The important thing that is driving a lot of the application architecture and actually the infrastructure requirements is that now that you have implemented this method or this posture in your organization, a lot of the stuff that used to happen at the infrastructure level, they now happen at the application level, or what's around that application, right? So these teams are now usually more involved because they own what they build. They are more involved into operationalize this application code when it comes to high availability, disaster recovery, resiliency, scheduling, and this sort of stuff, right? So they are more in charge of that. So that's pretty much what you hear when you hear DevOps, and when you hear, for example, things like continuous integration, continuous delivery, continuous deployment. So once you have basically done all of those things that we have very briefly discussed here, now you can, with the push of the button, or even automate the entire thing, go into production all the way into continuous deployment, so that when you commit a new code into GitHub, for example, there is an automated process that will get you into production automatically. Now, not all organizations are that extreme, so most of them stop at continuous integration or continuous delivery, and then there are some manual triggers that goes into production. But this posture allows you actually to do all of those things that we have discussed here. One thing that we will get back in the later slides is this notion of infrastructure as code. So one of the key components of being able to push a button or even automatize everything in the process of going into production is this idea that you can code your infrastructure. So people that started using Amazon Web Services years ago, when they had to build like a virtual private cloud, or VPC, or some other infrastructure construct inside AWS, they wouldn't go on the AWS web interface and click to create a VPC. They would probably create a CloudFormation, which is a script in Amazon Web Service language that allows them to, with a click of a button, to deploy a VPC in production. So this idea and this notion of being able to code everything, not just the application, but how you operationalize it, is very key, and we will get back to that point. Now, if you are like, well, I'm years behind, don't worry. I mean, NASDAQ is year behind as well, right? So there are very, very few organizations that are actually capable of doing those things, but there is clearly a path that we are on to be able to do those things for everyone. So that's more for the operational aspect of it, right? So how you actually run the things. So from an architecture perspective, cloud-native applications. So again, if you ask 100 people, you will get 100 different answers about what a cloud-native application actually is. I took this angle in a blog post a while back, and I think I got some very good feedback from very knowledgeable people that that said, yeah, this is a valid angle to look at this. And one of the angles that I like to stress on is this notion of pets and cattle, right? So I assume that you, at this point, have heard at least of this notion of pets and cattle. Pets are those objects, typically VM or instances, that have a name and you cure. If they have some problems, you try to fix them. Cattle is just a bunch of instances. If one dies, no problem, you kill it and you bring up another one, right? So most organizations, maybe most of you, are using pads in your infrastructure, meaning that trying to disassociate the infrastructure capacity, like CPU memory that you're consuming, from the state of those instances is very difficult, if not impossible, right? So by state, I don't just mean data. I mean, do they have a name? Right? Do they have to have an IP address? Do they have to have a particular configuration file on the C drive or on the root directory? Do they need to have this particular code that needs to be on that particular host? So we're not talking about a file server, a database, which is obviously obvious, right? That's state, right? But everything that VM has, which is peculiar to that VM, has state. I remember talking to a customer many months back, and he said, I have this big infrastructure on 2 sites, right? And I'm completely resilient, right? So I can bring down a site, and I can keep working on the other one, right? And then I asked, how long is it going to take to bring back the original site? And the answer was, well, it will take months because we actually need to go through all the Excel, Word documents that we have that describe exactly what those applications and those virtual machines are running at the moment in terms of configuration, IP addresses, load balancer, and everything. That is most definitely not a cloud-native application architecture. At best, is a good DR plan, a good load balancing plan, whatever. But the key point is that the moment that you have state in your instance is going to be very, very difficult to support the model that we have described in the previous slides. The cloud-native application pattern is very different. So you have a clear distance between where the state is held and the infrastructure capacity. So when we start talking about Docker and containers, what happens is that we're going to talk more about this space here, right? So Docker and containers are very much used in this space where the ephemeral instances can be brought up and down automatically because you have persistency in another part of the infrastructure. So this is a little bit foggy, if you will, because I had to remove some of the slide that gets into more details of these. But think about, for those of you that have explored a little bit the AWS model. So the AWS model pretty much has a bunch of services like DynamoDB, RDS, that allows you as a developer to keep state in here, in this red part here. And then you have a bunch of stateless services like EC2 and other services that allows you to crunch those data. So if you bring down like 25 EC2 instances in this model here, it doesn't really matter, right? Because then what you do is pretty much you bring back those instances and you make them point to where your state is, right? And if you remember the discussion that we have about infrastructure as code, so I want to actually code how I build those EC2 instances or those vSphere virtual machine for that matter. And I want to be able to actually create a script that can auto-deploy those 25 VMs if someone logs in and delete them, then you save the state into that bucket as well. So, as I said, this is a little bit foggy, if you will, but it will be helpful to remember this slide when we start talking about Docker and other things, right? So basically, those ephemeral things are consuming this data here, but in here, I also have the infrastructure state, right? How my infrastructure has been built. I don't have to have a 27 pages Word document that describes how I build my VMs, right? Because it's holds them. So that's pretty much where that agility comes in terms of being able to deploy new application in this architectural discussion. So now that we have kind of a little bit of the background of why people are doing these things, and at the very, very high level, how they're doing those stuff, let's start talking a little bit more about the technology, in particular about Docker and containers. So most of you are probably doing these today, right? So you have hardware, you have an hypervisor, and I'm using hypervisor in a very loose way, meaning vSphere, pretty much in this context. And then you have a virtual machine that has an OS and an application, okay? Containers, you can think of containers as sandboxes that run inside the operating system. And I apologize for those of you that have already started playing with Docker and containers if this is too basic. But for those of you that have been never exposed to the notion of containers and Docker, which we'll talk about in a minute, you can think about those as being able to wrap those applications in sandboxes that runs inside the operating system, right? Something that we're not going to cover in this presentation is this notion that you can actually, and there is some people that are advocating for being able to run those containers on bare metal, right? So we're not going to talk about these. This would require a session on its own, or you can tune on Twitter during the weekends. Lots of interesting discussion from thought leaders that discuss, whether you should use virtualization or everything. My point of view is that virtualization solves a particular problem in a domain that is not what Docker solved, which is more akin to the application lifecycle rather than the infrastructure management. But as we said, in the interest of time, we're not going to talk about these in this presentation. We're going to talk more about Dockers and containers, right? So one of the things that is usually source of confusion among many users is that Docker is containers, right? But it's not, right? So the idea is that basically there is this notion of a Docker engine, which is the thing that allows you to lifecycle your application. So basically, what you will be able to do is you will be able to do things Docker build, Docker push, Docker pull, and Docker run, which is a way to package your application, store it in a registry, getting it back and run it in your system, right? So this is more the life cycle of the application, right? Rather than a technology that is being used to instantiate that application, right? So basically, there is this notion of the registry where you build your application, your artifact, so to speak, or the Docker image. You can push it into a registry, and then you can pull it and you can run it, right? When you do a Docker run busybox, for example, what happens is that basically the system will go out to the registry, will get the busybox or whatever Docker image that you want to instantiate, and then Docker will use a container as a runtime to run that Docker image. This is very important to understand when we're going to touch and talk about VIC or vSphere integrated container, right? So you have to understand the fact that Docker and the life cycle of the application that it provides is different than the technology that Docker uses to instantiate that application, which is the container, okay? Remember when we talked about infrastructure as code and trying to code everything? So when you have your jar file, or even your script, whatever that is, this is a script that I built, vic installer shell.sh, right? This is the Docker file, which is kind of, to me, the genius thing of Docker that allows me, the developer of that stupid thing, to wrap it around something that I can then distribute without having to tell you, oh, well, to run my script, you need Python, or to run my script, you need Ruby, or to run my script, you need this particular library. Because I, as the developer, as the builder of these stupid thing here, which is a very stupid script, I can create a sandbox around it so that I can ship it to you and you can run it without having to pay attention to the runtime that you need to have and the prerequisite and everything. You know, the notion of, well, it runs on my laptop, why you shouldn't run in production? Because what you have on your laptop is completely different than what's running in production. So the Docker file allows you to create this sandbox and actually to codify this sandbox, right? So that you can then take this image that comes out of this Docker file and give it to someone to run without having to have any prerequisite, right? And the Docker file is actually where the state is. This is where it's defined how your infrastructure is being built and used, right? So that's where usually the Docker files are stored, right? In GitHub, for example. So when you build your application, you also check in the Docker file that comes with your application so that everyone can build that image if it's not available on the registry, right? So why are Docker and containers so much in the news today, right? So remember what we have discussed at the beginning, like DevOps and what comes with it and cloud-native application. Now think about Docker and containers, what they provide, right? Fast to start, sub-second. That's not like a virtual machine that takes minutes to boot. If you do a Docker run of a Docker image, it literally takes sub-seconds to run. It's a lean, small, self-contained environment, as we said, right? So you can create this sandbox with a Docker file that has everything in it, right? So it's self-contained, right? It's DevOps-oriented and self-service authoring. So this is a very interesting thing. In the context, thank you. In the context of you build it, you run it, if you have a way to build your application and then packaging it with those infrastructure as code mechanisms that we have very briefly touched upon, that's very convenient for a developer. So the developer doesn't have to take its jar file and walk around with, like, you know, can you put this in production? Oh, by the way, it requires WebLogic, blah, blah, with this particular fix, because now he can provide that sandbox for running that application without any prerequisite, right? This is the other smart thing that Docker did. It's super easy to share something that you have done. So I can go to my laptop and build an application, push it into a registry, and having you pull it like in a matter of 10 seconds, right? Think about being able to do this without this mechanism. How long would it take to me authoring that application and giving it to you? It could be days or weeks, right? And it's infrastructure agnostic. As we said, it's very convenient for developers working on their laptop to be able to package those stuff in that sandbox and then giving it to you and put it into production. So if you think about all of those stuff, the last one is one container, one process. So thinking about what we have discussed at the beginning, these microservices thing, so breaking apart this monolithic into many different pieces. Now this is very convenient if you want to break that all the way to one container, one process, which is actually how you should run Docker in the end. So if you think about all of these things here, And if you think about what we have discussed at the very beginning, like the DevOps posture and the cloud-native architecture or application architecture and pattern, you see why people are getting crazy about Docker and containers, because the value prop that they have is very akin and very close to what you will need to do to get to that level of operational efficiency, because some of the characteristics of this technology are very akin to that. Okay? Very briefly, because we only have like 10 minutes left, what we have discussed here is pretty much what we were discussing like back in 2002, 2003 in terms of virtualization in the hypervisor. So this is what Docker allows you to do, right? But there is a huge amount of things that needs to be done from a container management perspective to be able to move from Docker on the laptop all the way to running Docker in production, right? And if you run stuff in production, you know what that means, right? Reliability and you know, scheduling and security and networking, which is a big mess in the Docker world. So there is this learning cliff that needs to happen. So we're going to skip these few slides very quickly in the interest of time. But what we have discussed so far is pretty much this, right? The landscape of what's going on around that, it's very interesting, right? It's a big mess. It is a big mess, right? We're going to skip this slide because it would take 4 hours and you will walk out more confused than when you walked in, trust me. But it is a big mess, right? And there are some interesting quotes. Sorry, we're going to skip these slides in the interest of time, as I said, but this is kind of a picture of what's going on. So when people talk about Docker, they usually talk about this. Docker is doing other stuff, like Docker Swarm and Docker Data Center. But that's Docker take to get to that level of being able to run in production. This is the gold rush, and many, many more startups and companies are working to do pretty much the same here. So it is a very complex ecosystem, and these are some of the names that you will bump into when you start digging into this. And this is obviously a moving target because it changes pretty much daily, right? So there were some interesting quotes on Twitter a few months ago where someone was asking, are we at peak of confusion? And someone said, yeah, 5 more scheduler and we're there, right? There are more scheduler today than, I don't know. And then there is this other one that was very telling. It's nearly impossible for someone to understand what's going on because this is the gold rush. Everyone is trying to get into that space because that's the space that most vendors think that can be monetized, right? So it's going to be interesting. I want to use the last 5 minutes. The last 5 minutes to give you a few hints about what we're doing in terms of cloud-native application and Docker/containers. So if you think about what we're doing, I mean, we're doing many things, like VMware Integrated OpenStack, we're doing vRealize automation. One of the things that we're doing, which is what we're going to cover during the Hack Lab this afternoon, fingers crossed, is this thing called vSphere Integrated Containers, right? So remember when I said that Docker happens to use containers as a runtime engine, but Docker is different than containers itself as a technology. So vSphere Integrated Containers allows you to do something like this. It will allow you to expose vSphere resources in a Docker-friendly way, right? So an object that is a container for a developer, but it's a VM for the system admin, right? So we'll get more into this in the afternoon if you come to the session, but basically, this is what we have seen before, and what we're doing is just this. So instead of doing all the circus and instantiating a container, we're instantiating a VM. So from a very practical perspective, this is what happens. And this is one of the #1 problem that many vSphere admins have today. Developers comes in, they want a VM, a Linux VM, a big Linux VM, and they are like, what's going on here? What are they asking this VM for? And 2 months later, they give the VM, they spec the VM with CPU memory, they give the VM or the IP address to the VM, to the developer. The developer runs some Docker commands, and all of a sudden they found like a number of containers running inside that VM that they have no idea about how to secure, how to operationalize, and do all these sort of things. So a big mess, right, for the IT organization. So vSphere integrated containers change this paradigm, right? So instead of giving them a Linux VM to instantiate containers, what we're doing is we're giving them what we call a virtual container host, or VCH. So we spec the VCH, which is basically a vSphere resource pool, if you will. We spec it with CPU and memory. We give the IP address of this proxy VM that you see here inside the resource pool. So when they do Docker run of NGINX or whatever, what happens in the backend is that they instantiate VMs inside that resource pool that you know as an IT organization how to deal with, right? Because now they are VMs. You can secure them with NSX, you can monitor them with VROps, and you can do all sorts of things. We're going to explore this part in more details in the afternoon during the Hack Lab for those that are coming. The last 3 slides are, well, this is more a detail of how we build that VM interactively when you do a Docker run NGINX, for example. So basically, we take Photon OS, actually the kernel of Photon OS, and we actually pair it with a Docker image that we pull from Docker Hub or the Docker registry. And that's how we form those, what we call container VMs. Right? So that's pretty much, instead of instantiating that Docker image as a container, we instantiate that Docker image as a VM, but it's exactly the same thing. The other thing that we're doing, so this is more for those organizations that are like, I have no idea how to run containers in production, right? So I need to be able to operationalize them, leveraging what I have today in-house. Yeah, I'm done. The last 2 slides, the other thing that we're working on is Photon Platform. So Photon Platform is for greenfield deployments. I know how to run containers in production. I know how to use Kubernetes. I know how to use Swarm. I know how to use Mesos and all those kinds of things. So basically, what I'm doing is I'm leveraging a purposely built infrastructure as a service, which is just enough infrastructure to run those containers at scale. So if we go back to this slide, do you remember this slide, the DevOps model? Do you remember that we said that everything happens at a very high level? Who owns the application also owns how to operationalize it, and the infrastructure doesn't need to have all of those fireworks. That's Photon Platform. No DRS, no vMotion, no HA, because everything happens at that level. Okay, so it's a very different platform than vSphere. So this is vSphere, and this is Photon Platform.